quarter circle. With the same values for Q and A that we had over here. And then for the third one, I'd like you to do this, where you have two quarter circles, where one is positive Q and one is minus Q. We'll find E at the center. Are there any questions? Okay, what I would like to suggest, notice the axis of symmetry that I selected here. It cuts the charges in half. Okay, do I want that same axis of symmetry here? No. Why not?
It doesn't cut anything in half.
Doesn't cut anything in half, and because I'm going to have unbalanced components, I'm going to have an E dE cosine theta component that's going to add up. I'm going to have a dE sine theta component that's going to add up. So I've got to do two different ones. But I don't want to do that. I'd rather make this problem simpler and not go to so much trouble. So I'm going to choose an axis of symmetry that goes like that. Then I can still select my little dq charge elements as being an equal angle above or below my new axis of symmetry. Like that. But that will select for an electric field that points along the diagonal, and not for one. So if I did this with dE cosine theta and dE sine theta, and work this whole thing through, I'd get the two components of E. They would turn out to be equal to each other, and the angle would be 45 degrees. But we can solve this much more efficiently by just choosing a new axis of symmetry so that the horizontal components along the axis of symmetry add, and the vertical components cancel. And then we can just proceed as we did here, but with different limits of integration. Okay, that's the only difference then, is different limits of integration. And then doing this again for this problem, where this one's plus Q and this one's minus Q, you're going to need to set up an axis of symmetry that'll look like this for the minus Q, one that looks like that for the plus Q. So a lot of this is just kind of visualizing what's happening geometrically. I've already set the basic equation up for you. You've just got to correctly select the limits of integration. Any questions?
Yeah, so on the top it says dq equals lambda times ds equals
Right.
lambda. Is that,
That's from here.
yeah,
Total charge over total arc length. That's a little bit of charge over a little bit of arc length.
okay, so above that it's lambda q, no, above that?
ds is a d theta. So this is dq divided by a d theta equals lambda.
Yeah, so is it lambda q dq or lambda a dq?
Lambda is this, so just cross multiply. That's what I did here.
Yeah,
So it's lambda ds. That comes straight from here.
yes,
And I got the ds a d theta.
okay,
So I'm
gotcha.
just plugging them all in.
Okay, cool.
Any other questions?
Are we using those A and Q numbers for all three?
Yes.
Okay.
For the same. Now, are your lambdas going to be the same because I have the same q's?
Yes.
No, they're not going to be, because this is that amount of charge over half the length. So these two lambdas are going to be different than the lambda here. You have to be careful there too. Don't just assume that because you have lambda here that that's the same. It's not. They're going to be off by like a factor of 2. All right, and we've got a little time. I think it is well worth your time to see what you can do with these while you're in class, and we can help you. And then please read carefully over all of these sections, start doing the homework, and then we'll do a lot more practice. handicap drawing.